Good morning, good afternoon, good evening, depending on where you all are. Thank you for joining us today. My name is Jonathan Yaksha from TechConnect. I will be your host for today's Oil Sands Artificial Lift Challenge webinar. So thank you once again for joining us. I'm joined by Jesus from COSIA. He's going to talk to you about the technical details of the challenge. So let's dig into it and get underway here, folks. So first off, as I said, we've got Jesus with us. Hopefully Fernando will be joining us shortly to give you some additional perspective on things. On your left-hand side of your screen there, you'll see a quick agenda for what we're going to be covering during today's session. Very important, that penultimate bullet point there, Q&A. At any point during today's session, if you have a question about the challenge, go ahead and drop it into the Q&A chat box. We will spend a good chunk of our time today going through those questions. We've already got some that were submitted already, so that's fantastic. Like I said, at any point, drop them in and we'll get to your questions and cover just as many of them as we can, and we'll make sure that we get you some information. Likewise, you can see that we're going to talk about the timeline, the FAQs, how to respond. COSIA is going to give us some great information about the technical details of the challenge. And with that, let's get underway. So, why are we all here? What is COSIA looking for? That overview quarter sentence there is basically they want to find new technologies and innovations that will help them improve the artificial lift process in Canadian oil sands. That's right there in a very tight nutshell what they're looking for. Now, there's a lot of different ways you can go about doing that. We've listed out 4 of them here. Next generation electric submersible pumps. If you've got one, fantastic. They'd like to hear about it. Sensors for harsh environments. Intake redesigns. Novel impellers. One thing I want to say here, this is not an exhaustive list. If you've got something that could impact oil sand operations in the artificial lift process that isn't on that list, fantastic, we would like to hear from you. If you've got something that combines a couple of those things together, that would be fantastic as well. At the bottom of your screen, you will see a link there, artificiallift.techconnect.org. That is where you're going to go to submit your response. That is where you're going to go to learn more about the challenge, to review the FAQs, all that sort of good stuff. That is going to be your main source. That is going to be your best friend in this challenge. Okay? So, timeline. Really important one to start off the list. Submission deadline is a week from Friday. Friday the 13th. Friday the 13th, it's a good day. 8 p.m. Eastern time in the US. It's not a bad day. It's a good day. It's a good day to make sure that you get your submission in. And Jesus, I know you're with me on that one, so that's good. Now, you may be sitting here thinking that, hey, a little over a week and a half or so doesn't give me enough time to put together a really good response. Don't worry, we've got you on this. We're going to talk more about the response process in a little bit. You absolutely have plenty of time to put together a good, engaging, compelling response for this challenge. So if you've got a relevant technology that makes sense for this application, we absolutely want to hear from you, okay? So September 13th by 8 p.m., you are going to get your submission in, and we want as many of them as possible. Around about the middle of October, that's when we're going to send out notifications to the finalists saying, hey, we'd like to learn more about your technology. We'd like to invite you to the virtual pitch. So we're going to let you know in the middle of October. Towards the end of October, October 29th is when you're going to have that virtual pitch. You're going to be invited to a meeting with COSIA to talk about your technology so that they can ask you some questions about it. It's a great Q&A session with them. And then in early December, you're going to be invited, those finalists will be invited to Defense TechConnect in Austin, Texas for a showcase wherein you're going to get up and talk more about your technology because you would like your technology. You want people to know about it. So appearing at the showcase gives you that opportunity to talk to industry representatives, talk to government representatives, talk to VCs so that you can get some funding for your technology. Defense TechConnect is a great way to showcase your technology and what your company is doing. A couple FAQs. These are traditionally very common questions that we get. I like to throw them in here just so that people are aware of them right from the get-go. First off, are international responses welcome? Absolutely, yes. Part of why COSIA is doing this is because they want to broaden who they work with, and that is not just in terms of technology, but also in terms of geography as well. The more different kinds of technologies that they've got at the ready, the better for them. So if you are from Canada or the United States, great. If you're from Germany or South Africa or Japan, we would still love to hear from you. We want to hear from anybody and everybody that's got a relevant technology that can make COSIA's operations better. Is there a minimum TRL to respond? This is probably the most common question that we get. Short answer is no, there is not a minimum TRL to respond. Now, I say that the closer you are to commercial readiness, that is obviously of greatest interest to the members of COSIA. Why? Because then they can put your technology into operation sooner. However, if you've got an earlier stage technology, something that you're still tinkering with and still starting to develop, COSIA still wants to hear from you because this is a thorny problem, because they are interested in all different kinds of technologies that could impact their operations. So if you're early stage, maybe they can work with you to figure out how your technology gets to commercial readiness. So don't let the fact that your technology is maybe a little early stage and not quite commercially ready keep you from responding. Like I said, they want to know about all of the different options that they've got available that they could call on for this thorny problem. The last FAQ that I'll talk about here is, can you submit more than once? Yes. If you've got more than one relevant technology for this particular challenge, you can absolutely submit more than once. There's kind of two paths that you would need to consider. Option one, if your two technologies can operate independent of one another, you might want to think about two separate submissions. That way you can talk about technology A in its full extent and technology B in its full extent, rather than trying to cram both of them into one response. The other option is if technologies A and B work best together as one unit, so to speak, you might want to think about a single submission that talks about the unified performance that both of those technologies can deliver. So it's really a question for you about what is the best pathway to utilize your technology. Is it a couple of technologies that can be used independently in different scenarios? Then you might want to consider multiple submissions. If it's best if you use them together, then you might want to consider one omnibus response. Like I said, that's a decision for you to make. Now, talked a little bit about participation and how to go about responding to it. Like I said previously, you are not too late to submit your response, and you absolutely have plenty of time to put together a good, engaging, and compelling response. So what are you going to need to do? You're going to go to .techconnect.org. That is where the challenge lives. That is where the response form lives. You can take a look at all the information on the challenge page. You can take a look at a more extensive FAQ. You can take a look at the entire response form right now to see what kinds of information is going to be requested of you. And I actually, in fact, suggest that you do. Take a look at it. My colleague Laura has dropped it into the chat if anybody wants to take a look at it right now. Thank you very much, Laura. In the response form, you're going to be sharing some information about your organization, who you are, where you are, all that sort of good stuff. Contact information so that TechConnect and COSIA can reach out to you, because that's kind of important. And then it's some open text box questions that COSIA and TechConnect have put together for you to talk about your technology, what it does, why it makes sense for this particular application, why you guys want to work with COSIA, all that sort of good stuff. This last bullet point, provide a compelling description of your technology. That is key. A response to an innovation project isn't exclusively a technical document, nor is it exclusively a business document. You are providing a story to COSIA about your organization, about your technology, and why you want to work with them. So when you are putting together your story, you need to make it engaging and interesting. You want COSIA members to get done reading your response and say, okay, we need to talk to this person. To use an analogy here, imagine Star Wars New Hope, and it's literally just Luke sitting there on Tatooine and does nothing for 2 hours. It's kind of boring. Nobody's going to want to see the sequel. Nobody's going to want more information. But Luke goes out and has adventures. That is what you want to try to do here. You want to convince people that they need to pay attention to who you are and your technology, and you do that through your submission. So, some general response guidance for those of you who may be new to submitting to an innovation project. Be engaging and be informative. You know your technology, you know your company. Present information that talks about how impactful your technology is, how much better your technology is than competitors or alternatives. Talk about maybe performance improvements, cost improvements, size improvements, whatever the improvement is that your technology can deliver, talk about that. Be responsive. What do I mean by that? The questions in the response form really do mirror the kinds of information that COSIA is looking for, the kinds of information they are going to use to make their decisions on the finalist selection for the virtual pitch. So if you're looking at the response and you go, well, I don't really want to answer that question. I want to answer a different question. That's not going to help you very much when it comes to persuading COSIA that they should work with you. Be responsive. Answer the question that was asked. Now, it's an open text box, so you can formulate how you best respond to that question, but that's the kind of information that they're looking for. And if you don't give them the information that they're looking for, that's not going to be particularly compelling or engaging. Don't be repetitive. I have been doing this kind of work for about 10 years, and I've read thousands of submissions. And sometimes people will literally copy paste information from one answer to another. I'm not saying you can't do that, but I am strongly suggesting that you may not want to do that because you have limited space in the response form, in your response. It is not meant to be an A to Z, fully bespoke technical and business proposal wherein you talk about what you're going to do on day 1, day 90, 180, and 270. It is an introduction. So don't take the limited space that you have to repeat information unless it is strongly, strongly important in your response. Because otherwise, you're taking space that could have been used for sharing new and good information with the reviewers. Last on that list, keep it non-confidential. The very first thing that we will do once this challenge closes is we're going to look at all the submissions and see if you have inadvertently included confidential information. And if you do, then we got to go back to you and say, hey, listen, we can't take this in its current form. And if we can't get a hold of you, or if you can't turn it around fast enough, we may have to exclude you from consideration. So make sure that all of the information you are presenting, regardless of where it is in the response, is non-confidential in nature, okay? Be vigilant about that, because I have to be vigilant about that as well. So if we work together, we can get through it really quickly, and I would appreciate that. And I know COSIA would as well. So I've been talking for about 15 minutes straight here. I'm going to turn it over to Jesus. Jesus, your slides are up on the screen. Let me know when you are ready for me to advance the slides, and take it away.
Thanks, Jonathan. I'm ready. So I'm Jesus Chassin, supervisor at ConocoPhillips Canada in oil sands. And so next slide, please. So I'm here representing COSIA. So COSIA is the Canadian Oil Sands Innovation Alliance. It's a group of operators as ConocoPhillips, Suncor, CNR, and those companies that you guys pretty well know, that are in the business of producing from the oil sands. This particular challenge is on in situ production. Oil sands can be mined, and I'm sure you guys know about that, but we're talking about the oil sands where we apply a process called SAGD, steam-assisted gravity drainage, in which wells are drilled in pairs, uh, uh, an injector and a producer. You have a cartoon there where you have the injector where there's an arrow showing that we put down steam and non-condensable gas, methane. The non-condensable gas helps the process in the reservoir. You see a long horizontal there on the steam well on the injector. There's also another well, the producer, where the emulsion of the original bitumen plus condensed steam, water, 70% water is usually what we get back from the steam, and you produce it with a pump. You could produce it with gas lift for a while, or rod pumps, very seldom, but mostly with electrosubmersible pumps. And so the mixture is that's being lifted. It's an emulsion, sometimes water in oil or oil in water with 70%, 80% water, and some returns from the methane. And that return is non-condensable, so the pump should be able to handle that. There is a couple of SAGD is a new process, 25 years in the making. And we're still learning how to operate ESPs effectively at the very end of life. When we inject more NCG, we inject less steam, and we use the steam for newer wells. And that is the challenge that you'll hear me talking a little bit more in the next couple of slides. Next slide, please. So here is the injector. We're only showing the injector. And these are wells that are typically in the 200, and I'm going to talk metric, okay, because we're here in Canada. So roughly in the 200 to 450 meter true vertical depth. And then they have a lateral section. This is that cartoon is not to scale, where we have 800 to 1,000, sometimes 1,200 meters long horizontal. It's probably undulating, likely undulating a couple of meters up or down. And that's completed with usually a 7-inch liner or flow control device. And the pump is usually located in the vertical or deviated section are between 70 to 80 degrees from vertical. So just getting close to horizontal. Most of the applications are with the pump intake pointing down, as it's better for preventing slugs from getting into the pump. The typical sizes of tubulars, the pumps are 5.6 inches in diameter, although we have some smaller ones. They produce through a 3.5-inch tubing. We have some cases where we have smaller tubing, 2 7/8. The motor is electrically provided with power from the surface. Horsepower is in the range of 200 to 100 horsepower. And the next slide, please. There is a little table there with some ranges of the variables that people working on pumps or artificial lift will find interesting to define the range of the equipment to lift under our SAGD conditions. So we're talking about in cubes per day between 250 to 1,200 liquid. In addition to that, sometimes we handle between 15% to 85% free gas at pump intake. More typically, we are in the 30 to 35 range, and the ESPs are fitted with some specialty stages, shroud devices, separators to help handle those conditions. In terms of pressures, pressures at pump tank anywhere from 750 to 2,200 kPa. And most importantly, the last line on the table is temperature. Those of you who know pumps and downhole pumps with downhole motors, they are they have some inefficiencies, so they generate heat. So they have to be cooled. The challenge in SAC-D is that they have to be cooled with water that comes back from the condensed steam that flows usually at 200 to 220 degrees C. So you're cooling a motor with 220 degrees C water. That's a very, very challenging situation. So technology has evolved in the last few years, maybe 10, 15 years, and pumps are able now to handle those conditions and last between 2.5 to 3 years. So obviously part of the challenge is to come up with ideas that will extend that mean time to failure beyond the 3 years that we are able to achieve now. Technically speaking, there's 5 challenges. Number one is high temperature. Whatever you put there, the higher the temperature, the lower the mean time to failure. In particular, motors like we use in the ESPs, they experience thermal aging in the coils. The other challenge is around the seals. Wells are shut down because of different reasons. Sometimes we need to work on the well. Sometimes we have power outages. When those happen, the well stops and the pump suddenly cools very fast. Those temperature cycles do impose a great challenge to mechanical seals, both elastomeric and mechanical shaft seals around the shafts. The latest, the third challenge, and the third bullet there, high GBF is becoming more and more of an issue as we approach end of life. As steam is injected, the reservoir is depleted of bitumen, and we direct the steam to other reservoirs, to newer wells, and we inject more and more non-condensable gas that returns. Those returns are free gas at pump intake, and electro-submersible pumps are spinners, are dynamic pumps that don't work very well when there is high contrast in density between the gas and the liquid. So that is a particular challenge for this condition, for this challenge that COSIA is putting out there today. Sand production, obviously the oil sands, so some sand comes back in the stream. So it is not quite a slurry, but it is 0.5% per volume type of sand, which will erode your pump parts. And finally, scale, chemical reactions that produce carbonates and hydrates that tend to clog the pump. Next slide.
Before we go on, I'll just say that for anybody who is looking at this chart right here and saying, that they need to quickly scramble to write down all of these numbers on the challenge page. As I said, the challenge page is going to be your best friend during this challenge. So if you're looking at these numbers and want to be able to reference them, it is available on the challenge page.
Yeah, I would like to say, because I forgot in the first slide, we'll provide. There's a couple of good. We didn't want to show some movies or anything. There's quite a few good resources in YouTube that will explain the overall SAC-D environment. And so Jonathan, we can provide those to people, right, to get a better idea.
Yep, we can absolutely.
So finally, landing on the challenge. So COSIA, like I said, is the Canadian Oil Sands Innovation Alliance. And we're in the business of cooperating among operators to better the efficiency of the Canadian oil sands. And in particular here, we're talking in situ production. So what we're looking for, this challenge is looking for, is innovative technologies to better lift in situ resources from the Canadian oil sands. The objectives are basically the ones that everybody's looking for: longer run times, shorter down times, improving well efficiency, and basically, if we can add here greenhouse gases, which is an overlaying challenge now that it's involving uptime, lowering operating costs, and improving well efficiency. That should be front and center also. So the scope is artificial lift. Any technology that would help lift SAC-D wells under SAC-D conditions, as we have more and more gas present in the mix, and as we flash steam, and I forgot to mention that, as we lower the pressures, the energy that's been put into the reservoir for ages or for decades will come back and will flash, and then will provide challenge to the pump. So The technologies include, but are not limited to, better ESPs, next generation ESPs that are better able to handle conditions that I mentioned before, novel designs of the ESP itself, or the components, or the sensors, or the cabling, or anything that will help be more effective in SAGD in situ lifting. Obviously, other technologies that come from other industries, the chemical processing industry, the aerospace industry, metallurgy will certainly be looked at and will be of interest to us. I think you mentioned that, Jonathan. I don't want to let it go. I mean, things that are closer to application, because we are application driven, will be better than. So you talked about TRL. So TRL 8 is much better than TRL 2, but everything is included from 1 to 9, like as you mentioned. Less mature, sure. COSIA is an alliance to help provide technology to all of us as an operating group. So less mature technologies that have a good chance to succeed will also be included. And the sooner and the closer to a pilot, the better it would be. But like I mentioned, any TRL will be considered. So
Okay.
that's pretty much what I have.
Great. Okay, so time to turn to Q&A. I've got a number of questions here already. As you're listening to Jesus and I answer questions, if you have a question, drop it into the Q&A chat box. We're going to take the rest of our time to go through questions. If you've got a ton of questions, that is a good problem to have. That means that you guys want to know more about the challenge. If we run out of time before we run out of questions, we will get you the information that you're looking for in those questions. So with that, I'm going to start off with our very first question. And Jesus, I think this is going to be a question for you. What will the background of the review panel be? Mostly technical or mostly business?
I think that the technical and business. I don't think we, as operators, we're basically technical people who make money. So both. I mean, things that are technically complex, but they have a chance to succeed, will be looked at. But essentially, it has to make business sense. So yeah, I would say both, with a strong component of business sense.
Okay. All right. Another one for you. I think we're going to stick with you for a little bit. What is the max pressure units? Could not read on your table.
Sorry, I didn't get that. Maximal pressure?
That was asking for the units for the max pressure.
The maximum, yeah, those are all KPAs, kilopascals.
Okay. All right. Hopefully that answers your question. If we didn't, go ahead and resubmit, and we'll take a look at it. All right. Yeah. What kinds of post-challenge engagement are possible with COSIA member companies? So basically, after the virtual pitch and after the showcase, how might a respondent work with COSIA members?
I think we have the COSIA as a group has worked together and has brought into practical application concepts in flow control devices, for example, and stuff like. So the work would be, supported by COSIA if it's of merit. I think the relationship would be through COSIA as an entity that is formed as an alliance by all operators. So it's a way that we have worked in the past.
Okay. I think the question is more along the lines of, and if I'm misunderstanding the question, please let me know. What might the relationship look like between COSIA and the individual respondent? Is it likely to be joint development or technology licensing, that sort of thing?
I think both have happened in the past. I would think it would be case dependent, right? If there is a, a company that is already a vendor that is coming from and is ready to field trials, it will probably be a corporation where we put their equipment in our wells. If it is an inventor who is looking for, or a small high-tech company that's looking for seed money, that has been done. I could say that ConocoPhillips has done it in the past, and I'm pretty sure that COSIA would do the same thing. So I think it's basically a corporation, as was put in my last slide. We're looking for ideas that, if they're the proper idea, we will collaborate to make it happen if the merit is there and the benefit is there. So there'll be various ways depending on the case.
Okay. So would you say that a potential respondent should give some thought to how they might want to work with COSIA and then include that kind of information in their response? For instance,
Yeah,
if they're looking for a joint development agreement, say, I'm looking for joint development. If they're looking to license their technology, indicate that that's where their interest is.
yeah, I would say that that wouldn't hurt at all. That would be very helpful to know upfront what are the expectations from the company or
Okay.
person proposing the idea. That's always better than when we're evaluating the idea, is just thinking about what might be in their mind. If they put it up front, that's always easier.
Okay. All right. Do the ESPs have SCADA support? What sensors are used and monitored today?
Yes, they do. So we the different operators work slightly different. Inside the issue, yes, we have SCADA support. Yes, we have control room, like you would imagine in an oil field, with some nuances because of the temperature. So we are not heavy on downhole instrumentation, basically because sensors don't last and they're not reliable, and they last a year or so, while our pumps can last 3 years. But we do use uh, distributed fiber optics, encased fiber optics, running down all the way to the end of the horizontal, where we have the reservoir, and we use temperature. This is fiber optics, so we can measure temperature and infer flow through the whole horizontal that goes by the pump. So we use it too. So temperature is basically the best and most sophisticated measurement we take. We use bubble tubes with nitrogen to have downhole pressure sensing, uh, and uh, and everything else at the surface is kind of the same thing that's being used for ESPs all over the world. So
Okay. You talked a little bit about protection for the sensors that are downhole. Next
yeah,
question kind of aligns really nicely with that. Do you need protection on inside zones of tubes as well for diffusion?
I I I kind of lost the
Oh,
last
sure.
3 seconds of your questions.
Sure, not a problem. The question is, do you need protection on inside zones of tubes as well for diffusers and pellers? So I think the question is asking, would approaches for protecting downhole components, whether it's the sensors or diffusers or impellers, would that be something that would be in scope here?
Yeah, it would be. I mean, coatings, for example, for erosion would would be something that we in scope. We If it's a better coating than the ones that we use, for example, and if there's a reason behind it, or different geometries and arrangements within the stage, for example, those things are known to us. I mean, every supplier of equipment has a slightly different variation and protected know-how on how they distribute the flow and the geometry on the internals of a stage, right? So with the spacing for the different types of this sand grain distribution. So yes, they'll be in scope. Anything that could be an improvement on what we have now, it is certainly in scope.
Okay. Um, okay. This one's kind of, in effect, going to motivation. What is the impact of a failed ESP? And do you have a rough cost estimate for a failed ESP?
Well, I would certainly, I'm gonna, because I'm talking for a group of companies, right? And we certainly don't share our. So I could briefly talk about orders of magnitude, and that's one reason. The other reason is that we don't divulge that information because it's
Sure.
competitive information, right? But a typical ESP is a couple of 100,000 to 500,000 kind of range. When it fails, you have to replace that. If you fail a well because you sand it, because you try to explode it, it's probably a couple of million to redrill. I'm talking Canadian. And the netbacks cannot be disclosed, right, on a per barrel basis. But every down day, your average well is 1,000 barrels a day, and you're losing that at current prices, which are high. And if you fail here, your time to replace is probably on the average of 10 days, 10 to 14 days. I think I'm accurate there. So 1,000 barrels for 10 to 14 days and 250,000 to $500,000 on the pump, you could start adding the impact of having a failed ESP, right?
Okay. All right.
Sorry for being vague, but it's something we don't.
No, I think that absolutely makes sense that, COSIA represents a number of different
Yeah,
organizations. And also just for right now, it, like I said, it's not meant to be a fully detailed business proposal saying, if you do X, this is going to be the definitive cost savings or improvement. It's more of an introduction to, if it's roughly this and our technology can roughly do that, this is kind of an order of magnitude, like you said, of what kind of improvement you might be looking at.
I would turn around and say if it wasn't valuable and desirable, we wouldn't be having this challenge. It's you know, I think maybe I could, in addition to that, I could say if we could extend the life of the reserves on a reservoir that we're blowing down, and we because we have a fixed capacity of steam that we're putting into the new wells that will run for 20 years, you don't want to keep building steam generating capacity for greenhouse gas effects, or because those are large capital investments. And then you have this chamber already energized, but you're not putting too much energy just deflating. If you can deflate it in 2 years or 3 years or 4 years or 5 years, because you still have oil there, you're going to have a lot of gas, right? And so your ESP is becoming effective. You can quickly see how valuable it would be to have artificial lift that could handle those conditions, right? So it is huge. That's all I can say.
That'll work. All right. Next question. Sticking with sensors. Do sensors fail because of the harsh conditions? Would you consider rugged sensors that last longer? Let's go ahead and say, yeah, sensors was one of the
Yeah,
things that we had talked about.
yeah,
Yeah.
yeah,
If you got a
yeah,
sensor that can handle the kinds of conditions that
yeah,
Jesus was talking about in his
yeah,
chart, yeah, bring it on.
yeah. At the right cost, right?
Yes.
Reliability and cost, and the same thing that is true for any equipment, right?
So, if you're looking at it and you have a sensor that fits in with the
Yeah,
parameters that are listed on that chart, talk
yeah,
about how your sensor operates under those kinds of conditions. Let COSIA know that, hey, your sensor is really good in high temperature environments, is really good in a harsh physical environment, whatever it may be. Talk about that because that's what you're trying to convince them that, hey, your sensor is going to work for this particular application.
yeah.
All right. Next, uh, can pathways support pilot scale testing?
Yeah, certainly. I think we've done that. Yeah.
Okay. All right.
In fact, I would say the on the TRL scales, pilot is the way to go. I mean, we would small trials and then go moving into larger pilots when you really have to put the technology to the test on the breadth of conditions, right? That you have, certainly.
I'm actually going to build off a little bit on this because you're not stipulating a minimum TRL, would it be fair to say that you guys are open to pilot scale testing pretty much on an as needed basis? As a technology reaches let me backtrack a little bit. As a relevant in scope technology reaches a point where it could be pilot scale tested,
Yeah.
that is something that you guys would be interested in looking at.
Yeah. 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 The idea has to be compelling like anything, and then the chances and the possibilities. So it will go through a rigorous process of evaluation by the COSIA members, but certainly yes.
Okay. Next one is actually going to be for me. What is the format for the virtual pitch in October? Okay. So while the details of the virtual pitch are still being worked out, broadly speaking, you can expect to have a set amount of time to present an overview of your technology to the COSIA panel. You're going to be able to talk, again, in a non-confidential way about your organization, about your technology, and how you feel that your technology fits within the scope of the challenge, how your technology exceeds what's currently available, all that sort of good stuff. That set amount of presentation time is going to be followed by amount of time for the COSIA panel to ask you questions about your technology and to really get into a good back and forth there. For those respondents that are selected for the virtual pitch, you'll get all of those good details about what the virtual pitch is going to look like in that notification so that you have ample time to prepare your presentation for the virtual pitch. All right. Back to you, Jesus. What's most of interest? Completely new ESP or partial solutions that bolt on to existing ESPs?
I don't think I mean, I have a preference, right? I mean, I think that my particular bias would be something that adds on to something that you have, right? And it could be commercially viable, because where's that idea coming from? It's probably easier to implement and easier to see, but you know, a completely different system that it is quickly driven from the surface without having to change too much of the hardware. In other words, a non-ESP, but it's downhole driven with cable, and you don't have to change anything else. So you just change one pump by the other. Is as attractive as just as an add-on, right? Because you're basically not changing all the hardware around a node well. What you don't want is, and I'm going to make just an example as an analogy. You completely change a downhole power driven type of artificial lift like the one we have in late life, and then you have to change the wellhead and tubulars and the arrangements of tubulars on the wellhead. That's clearly a no-no, because it will not make economic sense in late life. So I would say that no particular difference, as long as they don't change your economics in late life.
And actually, the next question kind of builds off of that a little bit. Would you be interested in or looking for an ESP health monitoring / predictive maintenance solution that is a bolt-on to current ESPs? So something that's going to give you insight into how that ESP is performing, so that maybe you can get ahead of any potential concerns. Is that something that would fit?
That is in scope. Certainly, we are working on things like that right now. So yes, would be interesting. But we're looking for ways of lifting, but this is in scope. I mean, my first preference would be ways of lifting as opposed to something we're already working on. But if that kind of concept of on-condition monitoring to prevent and extend life, if it's a very great idea, we're already working on it, and welcome. I mean, we'll welcome such an idea also.
Okay. Kind of akin to the fact that there's no minimum TRL. How large of an impact on operations does a technology have to have in order to be of interest for you?
How large in terms of our? I mean, we're, we are on the end of life, right? So um, it has to be large, right? It has to be. It's kind of hard to say go beyond answer the question without being qualitative, right? I mean,
Sure.
can we produce a number to say if it's greater than NPVX, will it be attractive or not? But so I think it's kind of a hard question to answer at this point. I think we have to look at the specific proposal and see if whatever needs to be put in terms of or development or final development versus the promise, right? And the expected reward. But what I would like to say is, I would like to repeat what I said earlier in the previous question. The opportunity to extend life in a reservoir that still have 10-15% in situ oil, original oil in place when you're blowing down the chamber is huge. I would say is equivalent to the large number of stripper wells that exist in the U.S. and people keep putting barrels out, 2-3 barrels per day on a well because you still make money. In the case of a chamber, you have depleted the energy of the reservoir and you have a lot of gas and water coming back, but you already made the investment. So the extension of life, there is a lot of money in
Okay. All right. This next question here, I'm actually going to take a first stab at answering it, and Jesus, I want you to tell me whether I'm on the mark or not. The question is, do you have a dream solution for this challenge, a wish list? And I would say that what COSIA is looking for here, and please correct me if I'm wrong, you guys are looking for any technology that can give you good, sustained, efficient operation of oil sands wells,
it.
whether that is a brand new ESP, next gen ESP sensors that can help you do it. That's your wish list here is technologies are going to help you do that. Yeah.
Yep.
Okay. All right.
Yeah, it's an overall artificial lift challenge with the framework of the problem. It could be for the whole life cycle of a SAGD um, operation, lifting. It's about lifting the whole cycle, which is 20-25 years on a well basis, with a focus on late life, because that's where we're encountering the problem, right? And so an add-on at the end of life. Now, a novel artificial lift idea that you have to build a new pad for it is not unattractive at all, but it would have to be for a green field or a new pad, right? And we already have hundreds of pads. So, and as a COSIA group, right? So our immediate interest is the late life piece of it, but novel artificial lift for oil sands under high gas conditions is really the core of it.
Okay. All right, folks, we've got just 12-ish minutes left in our time today. We've got a couple of questions here. If you've got additional questions that you want to put to Jesus or myself, please feel free to drop them into the Q&A chat box. In just a little bit, I'm going to have to start wrapping things up. If you have a question while I'm wrapping things up, go ahead and submit it. Like I said, if we pass out of the Q&A section, we will still get answers to those questions. So what is the Defense TechConnect conference? Okay, so TechConnect is an innovation matchmaker. We bring together people who are looking for technology, Jesus from COSIA here, and people like you, people who have technologies that may be in scope and of interest to our clients. That is what TechConnect does. We do that through sprints and challenges, but we also do that through live in-person events. And at our in-person events, we bring together industry and government and VC for a multi-day on-site series of presentations and lectures and networking and expo floor to really get everybody to mix together and talk about their technologies and what they might be working on and how different technologies could address that. So if you are selected as a finalist and you're invited to the showcase, you're going to have the opportunity to talk about your technologies. You're going to have the opportunity to listen to other presentations, to maybe find people to work with, to sell your technology to, what have you. It is a great opportunity to mix and mingle with people who have technology, looking for technology, or looking to fund technology. So it is a great opportunity for you to learn about new things in your industry, new industries, and frankly, it's just a lot of fun. I'm required to go because I work for TechConnect, but I enjoy going because I get to sit and, quite frankly, get to nerd out and listen to everybody's presentations and see what people are doing. So it's frankly just a lot of fun, and I hope that you will consider responding to the project, if for no other reason because you would like to come to Defense Tech Connect. All right. Last question is a very simple one. Will this webinar be recorded? Yes, we are recording the webinar. We will put it up on the challenge page so that you can review it while you are working on your submissions. And for those of you that registered for this webinar, we will let you know when the webinar recording is up on the challenge website. And as Jesus was saying, speaking of recordings, we'll put links to those YouTube recordings as well onto the challenge page so that you have access to those. All right, we haven't had any new questions come in just the last little bit, so I'm going to go ahead and start to wrap everything up here. Like I said, if you do have questions as I'm wrapping things up, go ahead and submit them, and we'll take care of that kind of on the back end. So, thank you very much to all of our attendees for taking some time out of your day today. I know we've got some international participants here, so it's either very late in your day or very early in your day, and either way, we appreciate you taking the time to do it. Jesus, thank you very much for taking some time out of your, what is it, lunchtime, pretty much here to be with us, so we do appreciate that. And we'll get you out here in just a little bit so you can grab a bite to eat before getting back to work. All right, for those of you that were attending here, two really important things on your screen there. Number one, like I said, your best friend in this challenge, artificiallift.techconnect.org. That is where you're going to find everything for this challenge. Challenge information, that chart that Jesus was showing, because you want to be able to refer to those facts and figures, FAQ, and most importantly of all, the response form. Go there, take a look at the response form, see what they're looking for, put together a really engaging and informative response that tells them about your technology. At the end of reading your response, they should put that down and say, this is a team that we need to talk to. That is your goal. Everything that you put into your response has to be in service of that. So put together a really good story about your company, your technology, and why you want to work with COSIA. Last, in the red there, submission deadline, September 13th by 8 p.m. Eastern time in the US. So you've got about a week and a half or so to put together your response. That is ample time to put together a really good response. If you take a look at it, like I said, it's a few thousand words. You have the opportunity to append supporting documentation to prove your case. Take advantage of that. Keep it non-confidential in nature, but tell us a really good story and tell us by September 13th. September 13th, Friday the 13th, it's a good day. Make sure you get your submission in. With that, I'm going to go ahead and say thank you one more time to Jesus, to COSIA, to all of our attendees. Thanks for taking some time today. We appreciate everybody doing that, and looking forward to seeing as many submissions as we can. So thank you very much, everybody. Have a great rest of your day.
Thank you very much. Bye-bye.
Bye.